Good morning, everyone. I'm going to be talking you through the chemical reactions unit. This is unit 5. This is actually my favorite unit, so I do hope that we can come back soon because there's a lot of cool labs we're going to do together once we return. In this unit, I'm going to teach you how to determine if something is a reactant or a product. We will learn how to balance equations in this unit. We'll learn how to identify types of equations and reactions. And we'll use a list of solubility rules to tell if a substance is soluble in water and whether or not it'll split up into ions. So using that information, we'll learn how to write net ionic equations. We'll also use an activity series, which is a list of metals, and they're listed in order of reactivity. So you'll determine whether a reaction can actually occur based on that list. So a chemical reaction is when you have a change that cannot be easily reversed. So that's to be contrasted with a physical change. Physical changes include cutting something, if you tear something, if you mold it or bend it, if it changes state, like if it turns from a solid to a gas, those are all physical changes. You're not actually changing the chemical composition of that substance. Whereas a chemical change, a chemical reaction, does result in a new substance with different properties. So, for example, if I were to cut my hair, that is a physical change. But if I were to get my hair highlighted, that would be a chemical change. Well, in this section, in this unit, we're going to be talking about chemical changes. And when we do labs in this unit, you're going to be looking for evidences that a chemical change occurred. So some of the things you'll notice is that light is sometimes produced, a flash of light. Sometimes you'll smell a new odor. If you see bubbles produced, that means that gas has evolved. The color may change, and you will also see the temperature change sometimes. If you feel the test tube, it'll get colder or hotter, and that indicates that it's either an endothermic or an exothermic reaction. One other evidence that's not on this slide is that if you have two clear substances and you mix them together and all of a sudden it turns cloudy, that means that you have formed a solid. And the fancy word we use in chemistry for solid production is called a precipitate. So if you see a precipitate formed, that means you have created a solid by that chemical reaction. So what we're going to start to do is write chemical equations, and the reactants are always what you begin with. You mix them together, and those will form products. So that is what you end up with. And when we write a chemical equation, you're going to separate the reactants and products with an arrow, and we call this arrow the yield sign. So the reactants are always on the left-hand side of the yield sign. The products are on the right-hand side of the yield sign. So in this example, the question says, in the reaction above, is barium chloride a reactant or a product? So barium chloride, you now know how to name formulas. So that would be the very first one here. Since it's on the left side of the yield sign, it would be a reactant. In example 2, the question says, in the reaction above, is sodium hydroxide a reactant or a product? So since sodium hydroxide is to the right of the arrow, that would be a product. Now we're going to learn how to balance equations. And the first thing you need to know about balancing equations is that you can't manipulate the subscripts. Now that you know how to write formulas after you crisscross your charges for ionic compounds, or after you write the formula from prefixes, you want to leave those formulas as they are, so you're not going to touch those. So if you want to balance an equation, what you're doing is you're saying that the number of reactants equal the number of products. The atoms themselves are in the same number. So if you start with 2 hydrogens, you have to end up with 2 hydrogens. So you're making sure that both sides of your arrow are equal. Now, the way you do that is you add numbers in front of the formula. So you add coefficients in front of your formulas. So you can see coefficients is that big number that goes in front. Now, why do we do that? It goes back to the law of conservation of mass. You can't create or destroy matter. What you put into the reaction, you must get out one way or another. Again, it is going to change form. As you'll see in the following examples, like here, magnesium was by itself, but on the product side of the reaction, it's a part of a compound. Whereas hydrogen was part of hydrochloric acid, but on the product side of the reaction, it becomes hydrogen gas. So it will change form, but you should still have the same number of each atom. So you can tell from this example, the magnesium, there's 1 on the left side, and on the right side there is also 1, so that's balanced. But with hydrogen, there's 1 on the left and there are 2 on the right side. So we have to balance that. And the only way we can balance that is to put a 2 in front of HCl. And that means we have 2 hydrochloric acid molecules. So you can't just add an extra blue dot to balance out the hydrogens. You have to add an entire molecule, an entire unit, the blue and the green dot. So since we have both 2 hydrogens and 2 chlorines with that coefficient, now that balances the 2 chlorines on the product side. So you now have 1 magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines. So I want you to try these 3 examples on your own. Remember, you're not manipulating the subscripts. The only thing you can do is add coefficients. So try these, and then I will show you the answers and talk you through how I came up with those solutions. All right, now I'm going to walk you through how to do these examples from the slides. So looking at example 1, I'm going to look at each atom individually. So I have 2 hydrogens on the reactant side and 2 hydrogens on the product side. So that is already balanced, and I can move on to oxygen. I have 2 oxygens on the reactant side and only 1 on the product side. So I'm going to have to put a 2 in front of water. Now that gives me 2 oxygen, 2 oxygen. Now those are balanced. But putting that 2 in front of water gives me 4 hydrogens. So I'm going to have to put a 2 in front of H2 on the left side. So that's 4 hydrogen, 2 oxygen, 2 oxygen, and now my equation is balanced. So moving on to number 2, I have 2 nitrogen on the left. On the right, I only have 1 nitrogen, so I have to put a 2 in front. Now, putting that 2 in front, I have 2 times 3, so 6 hydrogens. So I need to have 6 hydrogens on the left side. So I'm going to put a 3 in front of H2. So that's 6 hydrogens, my nitrogens are both balanced, and now I'm done. For number 3, I want to give you a tip here. Whenever you see a polyatomic ion, and that polyatomic ion appears on both sides of the arrow, go ahead and balance that first. So the fact that there's no parentheses here tells me that there's 1 sulfate on the left. On the right, there are parentheses with a 3, so that tells me there are 3 sulfates. So I'm going to go ahead and put a 3 in front of H2SO4 to balance my sulfates. Now you can see that that also balances out each individual atom of sulfate. There are 3 sulfurs, 3 times 4 is 12 oxygens. Same thing on the right side, there are 3 sulfurs, 12 oxygens. So it just makes it a little bit quicker and easier to look at sulfate as a whole. All right, so now picking back up with this 3, that gives me 6 hydrogens. So I'm going to put a 3 in front of H2. And lastly, I have 2 aluminum, and I'm going to put a 2 in front of my aluminum. So now everything is balanced.